Hi friends, welcome back. Today we are going to solve LintCode problem 1078, degree of an array. This question was previously asked by GE Digital. Before we look into the description and the solution for this problem, I just want to mention that my channel focuses on helping people who are preparing for coding interviews and Java interviews. I have created a playlist which are frequently asked question by big tech companies like Amazon, Apple, Google, Facebook, Microsoft, and many other companies. So this playlist contains different all variety of problems like dynamic programming, optimization problems, linked list related problems, string related problems, priority queue related problems, and so many others like binary search and other problems. So that will give you a good head start on like if you are preparing for Java interviews. So please subscribe to the channel. So let's look into the description of this question. Given a non-empty array of non-negative integer nums, the degree of this array is defined as the maximum frequency of any one of its elements. Your task is to find the smallest possible length of contiguous subarray of nums that has the same degree as nums. Returns the length of the continuous subarray. So nums.length will be between 1 and 50,000 and nums I will be an integer between 0 to 49,999, right? So they have given us these two examples. So let's take the second example over here. So basically degree of an array, what it means is the maximum frequency of any element that is appearing in the array, right? So if you look at this input array, you can see the frequency of element 1, right? Number 1 is 2, as well as frequency of number 2 is also 2, right? So degree, as you can see, 2 appear two times and 1 is appearing also 2 times. So which means that maximum frequency in the array of a number is 2, right? So that is called as degree of array. Now they said that we have to find out a contiguous subarray whose degree is also same as this nums array, which is 2, but its length should be minimum, right? So let me just change the color so I can show you. So if we consider this subarray 2 comma 2, right, its length is 2 and its maximum frequency is 2, right? 2 appears 2 times and its length is 2. Now instead of that, if we consider 1, right, if we consider 1, then this one will be the array, right? If we consider 1, so now the length of this array is 1 2 3 4 5, right? 5 is the length, so we have to consider the minimum length, which is 2, and we have to return that into our output, right? So that is what the problem is. So let me just take out this color so we can again reuse this space. So now what we are going to do to solve this problem is first we will iterate through this nums array, one by one, and we will create three different maps. First is the start index map, second is the end index map, and third is the frequency map, right? Third is the frequency map. So start index map is what, like, so basically we want to capture the starting index of every number, right? So for example, one start index is 0, so you can see here, so we captured 0, right, for 1. For 2, the start index is 1, right? 1, this one, right? So you can see here we can got like 2 is equal to 1, right? So and for 3 we have start index is equal to 3, right? 0 1 2 3. So you can see here 3 is equal to 3. So we created a map which will give us the starting index for that number basically, right? The second one that we will do in this for loop is we are going to do multiple things in one for loop. So second thing we will be doing is creating a end index map, right? So end index map will be ending index of every number. So as you can see, one ending index is 4, right? So you can see here one ending index is 4. For 2, ending index will be 2, right? So for 2, ending index will be 2, and for 3, ending index will be 3. For 3, ending index will be 3. So we created start index map, we created end index map. And third thing we are going to do in this for loop is we are going to create frequency map that will capture frequency of all the numbers. So here, as you can see, one frequency is 2, for 2 frequency is 2, and for number 3 frequency is 1, right? So how many times the number appears in the array. So that's what we will capture in frequency map. So apart from these three things, in this for loop, what we are going to do is we are going to capture the maximum frequency that appears, right, in the array. So maximum frequency in the array appears for number 1 and number 2, which is 2, right? Maximum frequency. So that is what we are going to capture here, correct? So these three things we will do into the for loop, first for loop. And so let me just show you the implementation for this, so you will understand when we are talking like the example and implementation, it will be easy to understand. So first thing I did is I created 3 different maps. So start index, end index map, and frequency map, right? All our key is integer, value is integer, right? And then I created 3 variables. One is max frequency, another is L, and then length is equal to, I created, it is assigned as integer dot max value, right? After that we are going to iterate through the array nums, and then we will create this start index here, right? So let me just, I think it came on next line, let me just, yeah. So here we will first read the num from nums array, we will put it into start index. You know, when we are putting into start index, we will use math.min, right? So always we will get when there are multiple times the element comes into the array, it will always capture the minimum into the start index, right? And it will be opposite for end index, it will always capture the maximum I, right? Maximum I means maximum position at which that element appears, right? That is called as end index. And frequency map will capture the frequency of that number, right? So we will use get or default method of a map, you know. So in the beginning when there was nothing, we will just use 0 as default, otherwise it will get the value, right? And then it will increment that value by 1, right? Because we want to increment frequency whenever the number appears in the array. So that's what we are doing here. So now we are creating the 3 maps: start index map, end index map, and frequency map. After that we are capturing the maximum frequency, right? So max frequency is equal to, we are just getting the max frequency map dot get number, right? So maximum frequency also we will capture. So these 4 things we are doing in one for loop. So this for loop, if you can see it, this one time complexity order of n, right? All elements we are iterating through. And after that one is done, what we are going to do is we are going to iterate through the nums array again, and we will capture the, so let me explain it over here. So one for loop is done. Now next for loop, again we will iterate through this array, right? So whenever we read any number, we will try to, what we will try to do, we will get its end position and start position. For example, one end position is equal to 4, start position is equal to 0. So what we will do is 4 minus 0 plus 1, right? Plus 1. This will give us the array, like a sub array, right? So sub array that we will get, right? So if you look at this one, so if I'm writing it here, let's say write 1 2 2 3 1, right? 3 1. So this whole array we have to take, so its length is equal to 5, right? If we want to consider 1, basically, because why we want to consider 1, because it has the maximum frequency 2 that we have, right? The maximum frequency is equal to degree of array, which is 2. So we can consider 1 as a candidature, right, to find out if it is giving us the least amount of length. So now in case of 1 we are getting 5, right? We are getting 5. This whole array we have to consider for in case of 1, right? So that is one thing. So we will keep going. So now after 1 is done, we will get the 2, right? So 2 will come. So for 2 we will get the ending position as 2 here. As you can see, ending position is 2 here and starting position is 1. So what we will do, for in case of 2, we will get 2 minus 1 plus 1, right? So it is equal to 2. So 2 is the length of this subarray. I am highlighting this subarray, right, for you. So this is 2 is the length. So this is better than our previous length, right? Previous was 5, now we are getting 2. So similarly we will check for all other elements. Here only 3 is remaining, so for 3 we will not check because its frequency is 1, right? Frequency is 1, so we will not check 3. Frequency should match to maximum frequency, then only we will check, correct? For 1 it is matching to maximum frequency 2, and 2 it is matching to maximum frequency 2, so we will check for 1 and 2. So now once we are done, we will get the minimum amount of length that will give us the continuous sub array, right, with the same degree of array, which is 2. So this length for 2 and 2, it is 2, so that's what we will return as our answer here, right? So the same thing we are doing in this for loop. So we are first getting the number, we are getting start index, we are getting end index, and then if the frequency of that number is matching the maximum frequency, we will keep calculating the length and we will always get the minimum, right? So we will get end minus start plus 1, and we will compare with the length and we will get whatever is the minimum of those two, right? And then at the end we will return length. So that is the approach we are going to take to solve the degree of an array problem. So let's go through the test cases now, so make sure that it works. So we will take this second one first. So if we run this now, it should give us 2. So we are getting 2 because this 2 is as highlighted, right? So this is the length. So now let us take one little bit bigger example over here. So let me just take it. So now as you can see here, the maximum times element appear is 4, right? 4 appears 4 times here, right? So that is what the degree of an array is 4. So the maximum, like the minimum length contiguous subarray will be this one, right, that I am highlighting. So 4 4 5 4 4, so that is the minimum length subarray that has the same degree of array, right, which is 4. So 4 4 5 4 4, so total length will be 5. So 5 we should get it in our answer. So we are getting 5, which is correct, right? Because 4 is the number whose frequency is maximum in this array, which is 4, right? 4 appears 4 times. So we have to find out the as they can say, right, like the contiguous sub array, right, with length minimum, right, minimum length, smallest possible length. So this is the smallest possible length that I am highlighting. It is giving us 5. So now instead of 4, now let us say we just create one, like let's say 8. We create 8 here, right? And then we have another 8 here, and after that we have another 8 here, and another 8 here, and another 8, right? So now 8 has a maximum frequency 5, right? As you can see, 1 2 3 4 5, but this is the array which is minimum length now, right? So let's calculate this. 1 2 3 4 5 6 7 8 9. So 9 should be the answer in this case, right? So let's check it out. So as you can see, 9 is the answer, right? Because it is taking this subarray as the maximum, like smallest possible length subarray for the maximum frequency element, which is 8 here, right? 8 8 8 8 8 8 appears 5 times. So our solution works fine. So let's submit this. So our solution got accepted by LintCode. So this is the way you can solve degree of an array problem, which was asked by GE Digital in their past interviews. So we just solved it using the 3 different maps we created: start index, end index, and frequency map, and we calculated maximum frequency. And then just by using the map and their start and end index for every number, we will calculate the length of minimum, like smallest possible length contiguous subarray, right? So time complexity is order of n here, because we are having 2 for loops but they are separate, so both are order of n. So the time complexity for the algorithm is order of n. Space complexity of this solution is again order of n, because it uses three maps actually to store the elements. So again we can say that space complexity is on, right? And we already submitted our solution and got accepted. If you haven't already looked into my playlist of Leetcode and LintCode solutions, please check it now. It has over 100 solved problems explained with examples and Java code, and those problems were taken by big tech company interviews such as Amazon, Apple, Microsoft, Google, Facebook. So those are like frequently asked questions in coding interviews, so please go through them. Also, if you are preparing for telephone interviews, then Java interview playlist is there that captures all the frequently asked telephonic questions about Java, and how to answer those questions is also discussed there, so please go through that. If you find this video helpful and if you like it, please subscribe to the channel and like the video. Your subscription is really important to us because that is the way the video can reach to more people. They can also watch the videos while they are preparing for their interview preparations, and they can get help by looking into the videos. So please subscribe to the channel, and thanks for watching the video.